Hello, you are welcome. I have a question here on simple harmonic motion of a spiral spring. Now the question says a load of 0.2 kilogram is attached to a spiral spring to give an extension of 0.04 meter. If the spring is pulled vertically downward by 18 centimeter and allowed to perform simple harmonic motion, calculate A. The period of oscillation. B. The maximum potential energy of the spring. C. The kinetic energy of the motion at 14 centimeter from the center of oscillation. And we are given acceleration due to gravity as 10 meter per second square. Now let's start by writing out the given parameters in the question. So I'll say solution A, that is solution now. The first parameter we are given there is the attached load, that is the mass that is attached to the spiral spring. And that is M for mass is equal to 0.2 kilogram. Then the next thing we are given there is the extension, an extension of 0.04 meter. So we take down the extension, which is 0.04 meter. And then what else are we given? We are given the vertical distance it is pulled before it starts the oscillatory motion. That means the amplitude. So any vertical distance it is pulled down before it starts the oscillatory motion is the amplitude of the motion. So that is capital letter A for amplitude, and that is 18 centimeter. Now, 18 centimeter, we are to express it in meters, which is the SI unit of distance in physics. So to convert this to meters, we are simply going to divide by 100. To convert centimeter to meter, you divide by 100. And that will give us 0.18 meter. And then don't forget that we are also given acceleration due to gravity. That is G is equal to 10 meter per second square. And then in this first question, we are looking for the period T. That is question mark that we are looking for. Now, for us to obtain this, we need to take, don't forget, this is our extension. I'll call it letter E. Extension, which is letter E, is equal to 0.04 meter. Now, the formula for the period of a spiral spring that is performing simple harmonic motion is given by T is equal to 2 pi square root of E over G. You can also use M over K. But here, since we already know the extension, we can use this direct. This is easier for us to use. So that will be equal to, now let's substitute the values, 2 times the value of pi, that is this 2 is written here, the value of pi, I'll take 22 over 7 for pi, 22 over 7, and then times the square root of 0.04, which is the extension. You can see that. That's the extension, 0.04. All over the value of G. G is 10. So by the time we multiply all these values, divide this by this, look for the square roots, multiply by 22 and 2 and divide by 7, we are going to get the final answer for the period as 0.398 seconds. So that is the period of the spring. So we are through with question A. Now let's move on to the B part of the question, that is asking us to find the maximum potential energy. That is the maximum potential energy of the spring. For us to find that, first of all, I would like us to find the value of K. Don't forget, from Hooke's law, we have F is equal to KE from Hooke's law, because we are dealing with a spring here. And from there, I can say E is equal to F. But in this case, we are not dealing with F, rather we are given the mass of a body. And when we want to convert mass to force, we simply use the weight of the body. So in place of this F, I can simply use the weight of an object. And then all over, the value of K is what we are looking for. K is equal to the weight now, which is like F, divided by E. When I divide both sides by K. By E, I mean. So now, let's go on. The value of the weight is mg. Don't forget, the weight of a body is the mass times acceleration due to gravity. This weight is equal to this. When you are converting mass to weight, you simply multiply by acceleration due to gravity. And then the extension is given to us there as 0.04. So that will be 0.04. So I can still substitute values now as m, which is 0.2, and then multiply by g, which is 10, all divided by 0.04. And that will give us the value of K as 50 Newton per meter. So this is the value of K. So now don't forget, it is not K we are actually looking for. We are looking for the potential energy. So the formula for potential energy of a spring performing simple harmonic motion is given by half K A square, half K A square. A is the amplitude. So we can now substitute values to get our answer. So it will be equal to half times the value of K. We already know the value of K from this part as 50. Don't forget, our K is 50. So I'm going to write 50 multiplied by the amplitude, that is A square, the square of the amplitude. The amplitude is 0.18 meter. You can see it here, amplitude 0.18 meter. So we're going to square it. So 0.18 square. So by the time we square this, multiply by 50 and divide by 2, it's going to give us the potential energy as 0.81 joules. This is the answer for the potential energy. So finally, let's move on to the C part of the question. The C part of the question says we should calculate the kinetic energy of the motion at 14 centimeter from the center of oscillation. So we are given the value of x in this case. The distance from the center of oscillation is taken as x. The amplitude is taken as a, and the distance from the center of the motion is taken as x, which is 14 centimeter. So in this case, I can start by writing our s. Let me write our s as 14 centimeter, which is equals to convert centimeter to meter, we divide by 100, and that will give us 0.14 meter. So our x is 0.14 meter. So now to calculate the value of the kinetic energy, the formula to apply is given by KE, that is kinetic energy, is equal to half K multiplied by amplitude square, the square of the amplitude, minus x square. So this will give us the kinetic energy. So this is the formula for the kinetic energy. So let's substitute values now so that we can get the kinetic energy. So I have 1 over 2 multiplied by the value of K. As we already know, K is 50. See it here. So this is the value of K, 50. So I multiply by 50 and then multiply by, open bracket, A squared. Don't forget, the amplitude is 0.04. Don't forget that value for the amplitude. 0.04, that's the amplitude. So we substitute that value and I write 0.04 square. Oh, sorry. The amplitude is not 0.04. Sorry for that mistake. The amplitude is 0.18. See it here. Is the extension at 0.04. The amplitude is 0.18 meter. So let's correct that. The amplitude is, let me write it, 0.18, and I'm going to square it and then minus the value of x. And the value of x is 0.14 meter. So 0.14 meter square. So simplifying further now, we'll be having the value for what we are to calculate there. By the time we substitute these values, 0.18 square minus 0.14 square, and then we'll multiply by 50, and then finally divide by 2 using this half here, we are going to get the kinetic energy as 0.32 joules. And that is the final answer. Hope you enjoyed this video. Please don't forget to like, share, and join for more videos like this. Thank you for watching.